Thank you very much, Paul. We had a session yesterday in which we heard mainly from farmers. That was the purpose, to find out what they felt about soil health. They knew they were doing something with it. What sort of indicators, what sort of metrics would they be comfortable with? We got some way along the line, but we found that it wasn't clear. One of the problems about measuring soil health is that certainly CA, which is disruptive of conventional farming, the interests of conventional farming obviously are expressed in the corporate world, in the government world, and in the science world. And we don't have a lot of heavyweight scientists here to tell us about soil health. We've got one and other people interested in science. What we have is a position in the UK and possibly here from Europe, from Gottlieb, where we just haven't got the science and the corporates and the government aligned with this particular activity. What we want to do is to have experience from North America and elsewhere in the world, especially in this country as well, what we can do about it. At this point, in this very dynamic meeting, which my mind has moved, as I guess yours have been moved by some of the very interesting things we discovered in sessions and over a beer, that we, there's a lot of, things have changed in my head in this period. So this morning we're going to try to get some sense of what metrics have been looked at, whether they're likely to be taken up, and I'll be inviting John Landers and others from the audience just to make a few comments as well from their practical experience. So the idea is to find out who has been producing metrics, indicators of soil health, what's been the process, and how successful has the process been in different parts of the world. So thank you. Can I, therefore, at this point, ask Jake Freestone, who spoke very eloquently from here this morning, to make the first contribution about his experience of metrics and soil health.
Thank you, Tony. I found this a really hard one to get my thoughts down on paper, actually, as I think a lot of practical farmers do. It's quite a new language that we're learning to talk, and like most school children who get to learn English and probably French or Spanish when they're small, they pick it up really easily. I'm not quite so agile in the grey matter department, so it is it's something new that we're learning very fast. I think we need to really sit down and have a look and try and understand what the implications are of soil health from a farming point of view, from a business point of view, and from an environmental point of view as well. And I think that will become clearer as we go on. I think there's three sort of main elements, really, from a practical farming point of view. There's the physical, the chemical, and the biological elements, if you like, of soil health. And I think we need to try and get some metrics around each and every one of those. I think physical ones, really, really easy to test when you're out in the field with a spade. Dig some up, crack it open. What does it sound like? Sound is a really interesting one, using our senses. Does it sort of tear apart? A great friend of mine in Canada said you can actually listen to the soil being pulled apart, and that's all the fibres in there, all the roots in there, and it actually makes a noise. If it's dead soil with no living matter in it, you break it apart, you crumble it, and it just is silent. And actually that's quite an interesting sort of thing to have a look at. Also smell, really important. Have a look at the smell. What does it smell like? Is it sweet smelling? Does it smell like the compost at the bottom of the garden? Or is it an anaerobic smell? And again, that's something I've really learned over the last 3 or 4 years. You just dig it up. It's the first thing I do. You look at putting it up to your face, breaking it open and smelling it. And if it smells sweet and almost edible, which is an odd, bizarre thing to say, then you know you're on the right tracks. A few times I've inhaled it too quickly and had to cough and splutter and spit. But, you know, we're all learning how to do this. Chemicals, I think, again, that's a relatively easy thing to measure. You send it off to a lab, you get a result. Is that result good or bad? Where is it on the sliding scale? And I think, again, that's also, from a no-till point of view, a really difficult judgment to make, because you're missing out that biological element in there that gives you the ability to see how available that nutrient is. So yes, it's got a value of 100, but actually does that mean that without the biology, that 100 is worthless? Or is 100 making it really available because you've got great soil biology and actually your plants aren't telling you that they're deficient? And then you come down to biology. So the biological elements of the soil, trying to ascertain and measure those is something that I'm struggling to find the right sort of metrics, and there's a lot more experience in the room here to hopefully enlighten me as well as everybody else in here on that. But I guess if you look at the top of the food chain, there's a few observations that you can make. Counting worms, Jackie's 60-minute worm count, absolutely fantastic idea. Just to give a real handle on what you're dealing with, what's in your soil. But actually when you're crop walking, have you got fungi on the surface of your soil? You know, is there life there? Is there more birds there feeding on more insects? You know, that's all indicators that we need to try and keep records of so that we can look at how we're actually improving things. So I think I'm going to leave my very practical and very basic soil health knowledge there and pass on to Joel, I guess, next, who will be the Formula One version of my go-kart.
Thank you very much.
Okay, I'll talk slow if that helps. No, so I was in the session yesterday, and I guess I might reiterate a few things that I said then. This is a very similar discussion, but also I think Jake has also covered some of the key points there, so perhaps I'll just try and extend on rather than cover ground again. But I think, you know, he touched on the core principle there. It's this idea of chemistry, physics, and biology. And in terms of this ideal metrics or these, what we're kind of looking for, the key point has to be that there are many metrics that all get integrated. There will be no one thing. There absolutely will not and cannot be one thing. We should not dare try and simplify and boil down this vast topic of soil health into such simplicity. So much detail we'll miss out on the way through doing that. So it has to be pieces of chemistry, pieces of biology, pieces of physics that all come together. And we're looking at all of those. And then it's a question of, okay, well, which are the particularly important ones that make the short list there? Now, the point that I made yesterday that I then have to add on is I think that plant health has to then come into this picture. We have to include plant health with those soil health metrics because plants are an expression, a reflection of those soil processes. So I view plants as indicators of soil health. And okay, that might be tissue testing, mineral analysis, bricks, sap measurements, nutrient quality, nutrient densities, and that's something I'm sure Dan can elaborate a little bit further on, so I'll leave that one. But the point has to be that plants sit in this picture as well. And of course, all of these things then have to have some kind of a reflection on production, on economics, on the health of the ecosystem, on the health of the people eating these foods. So, you know, it does unfortunately have to extend a little broader there. We need some tangible implications, outcomes of what these measurements are. You know, and so one example is often heard, well, yeah, I appreciate that earthworms are really important and that they're a great indicator of soil health, but I don't get paid on earthworms. You know, this is the comment that many farmers will say. And of course, that's absolutely fair and valid, but nonetheless, so we have to then say, well, okay, what about earthworms? What about all these other things and metrics? How do they influence production? How do they influence my overall economic profitability, viability, etc.? So I think obviously that piece of the puzzle has to come in, and I won't talk about earthworms, I'll leave that for the other specialists, absolutely. But I think we can all agree carbon, organic matter, I mean, this has to be a central piece of this discussion. Again, that's a nuanced discussion. It's not just about quantity of carbon, it's also about quality. And the water gets muddied further. And again, we don't necessarily have all of the exact answers around that, but which are the best forms of carbon, forms of humic compounds, substances in the soil that are most stable, therefore more of interest to soil health, functionality, etc. You know, carbon is obviously, it has to be there. And I think then maybe just in the point I also made yesterday is I just think that we also need some unity around this issue. The reality is that, although we may not be able to put our finger on exactly the soil health metrics and this or that, the reality is they'll all have pros and cons. Each will have strengths and weaknesses, and that's why many of them need to come together. But I think we certainly can say, or can at least agree to in these early stages, although we don't have the gold standard answers just yet, in these early stages, we can certainly identify if we're moving in the right direction. There are certain changes that we can see in soils fairly quickly to at least tell us if we're moving in the right direction. And if we know we're at least heading in the right direction, okay, on the way on that journey, we might then, it gives us time to work out what the gold standard is, what the exact metric should be. So I think looking for indicators of right direction is also important. And then this point that, in fact, there are many strategies that we can all do to improve our soil health, no matter if we are a horticulture, arable, livestock producer, mixed farmer, no matter if we are no-till or a cultivated farmer, tillage farmer, or if we are organic or conventional. The reality is that amongst all of those differences, there are many, many points and strategies that can be used, that can be implemented for every single one of those farmers and every single one of those production systems. Of course, there'll be differences, and that's fine. That's another discussion. The point is there's lots of overlap, lots of things we can all be doing together, getting ourselves all on the same page and agreeing two lists of protocols, strategies to move forward and improve soil health. So, okay, I love Venn diagrams for any of you that come to my talks. We're simply talking two circles that are overlapping. If I said that to you, vision in your head right now, two circles overlapping in a Venn diagram. Just picture it for me. What is it that you see? You don't have to answer. It's a rhetorical question. All I'm saying is that when you make that vision, when you bring that vision in your head, think about, rather than it being those two circles with a little quarter that overlaps. I don't know if many of you, in your vision in that you just had a little slither that overlapped. Just push those two circles together and have a little slither of differences on the outside and push them together and say, actually there's a lot of overlap in the middle. That's how we need to think about Venn diagrams and strategies for unity, so we can actually break down those barriers of differences and work together moving forward. So, okay. That'll do me.
Thank you very much. Dan, could you come next to give us some North American perspectives and what success you've had with metrics over there?
I'm not sure about North American perspectives. I'm not sure the rest of the continent would want to acknowledge me, but that was a joke. The first question for me is why? Why are we doing soil health metrics? And as a farmer, primarily, I think, we are wanting to engage in soil health metrics so that we can do a better job. And I think systemically, one of the issues with science and the way that it's been performed, especially in relation to agriculture, is that it has been performed in a very reductionist manner, with very, clear agendas behind the scenes. And I think this sort of idea that things can be understood by looking at the parts, I think it was, who was it? Descartes, 400 years ago, said we can understand reality by understanding the separate parts, presumes that life is not the foundation of reality. And I think there's the rub, there's the mistake. Foundationally, we're talking about living systems, in which all these different components are synergistic. And so I would suggest that the reason we would want to be exploring soil health metrics would be for us to understand where our limiting factors are so that we can most efficiently, with the least cost, get the best result on our farms. Just talking here at the beginning before we got started, the point was that really industry's not here, governments aren't here. It's the farmers that are pushing this forward. It's the farmers that have the incentive. And really, if we're having this conversation as farmers, we need to be thinking about what are our objectives. And our objectives are greater viability, right? Greater functionality, greater economic sustainability, for our families, for our land, et cetera. And so that being said, I think the strategy that we're engaging with the Real Food Campaign, which we're envisioning to be much more than just a North American endeavor, but more of a global endeavor, is a decentralized citizen science process through which farmers are willingly engaging in collecting data on all number of different metrics: soil types, fertility programs, management practices, cultivars, epigenetics, microbiome, climatic conditions, yields, pest and disease resistance, nutrient, aspects. No one of us is going to be able to collect every piece of data, but if collaboratively we can begin to tease together a big picture, right, using metadata and algorithms and all this fancy stuff with, the technologies now making available to us, I would suggest that as we, the people, smallholders globally, begin to bring together metadata, looking at many different metrics collaboratively, we will be able to tease out then which attributes are symbiotic, are crucial, are where our limiting factors are, and we'll be able to share with each other openly, transparently, not through industry, not through government, not mediated by salespeople, etc. But we, the people, can share with each other what seems to be the limiting factors, so we can empower each other to do a better job. I think science is a wonderful frame through which we can, collaborate. And science has been perverted by people with incentives that are not necessarily whole, and has gotten really a bad name, at least in North America. It's gotten really quite a bad name. I think true science, properly practiced, is a very powerful tool. And when you're dealing with living systems, you must understand that it is a really broad and multifaceted dynamic, and we're only going to be able to identify, likelihoods. We're never going to be able to say anything with great confidence in a categorical nature, and that's not the point. The point is not to be totally confident and arrogant and presume that you have the answer. The point is to be, guiding your intuition and saying, this is the likelihood here, experiment with this, and really to be supporting each other in this collaborative manner. Foundationally, we do all this for really visceral, self-interested purposes, right? Economic viability, livelihood for our family, et cetera. And so part of why we're focusing on the quality of the food as an organizing principle is we think that if we can work with people who are eating our food to help them understand that food that's more nutritious is what their children need, and we can shift the economic incentives so that farmers who are producing high quality food are the first ones whose crops are sold out, then we, as in, everyone's bought, not sold out like your sellout, then we have a visceral incentive to do this collaborative process. So, yeah, certainly we don't have the answers. Certainly we have a whole bunch of good ideas. I would just, I've been traveling across the aisles here, sort of west to east, and, from my North American perspective, everything that we need to know is already here in the collective. All the principles, all the practices, all the knowledge, there are people doing all the things that need to be done here and there and everywhere. And we need a structure for collaboration, for open sharing, and moving forward, I think in a collaborative manner. And if we are willing to engage science as a frame to facilitate that, I think we can really move forward quite rapidly.
Thank you, Dan, for picking up the point that we haven't got government here, we haven't got the corporates here to hold the hand of the farmers to make sure that the ideas that are the good ideas, the good practices that are being developed by the CA community are put in place, so we don't have big friends pulling us along. We've had some history in the past. In Australia, dryland farming went through this process in which people used to come out from Reading to tell them to deep plough, and they'd known for 100 years that they shouldn't deep plough. Eventually, they pushed back hard enough in the 1950s, 60s, and the science people picked it up and even made it seem that it was their idea. In Brazil, there was a similar moment when Embrapa embraced it, and that made it much easier to get the practice in place as well as the metrics to make sense. So we're in this position now. It would be great if we had the third, the science people, big science people here, who spend the millions. We have a wonderful friend and scientist here in Jackie Stroud. Her enthusiasm has affected everyone with respect to worms, but it's only a part of the story. But I'd like her to tell us how it is in terms of getting the metrics in place and adapted for CA. Thank you.
Well, hello everyone. It's a pleasure to be here to talk about soil health. And just to spend a second to mention about how I'm funded, I'm one of the 4 soil security fellows funded by the Natural Environmental Research Council with the aim to help improve soil science and work towards sustainable soils that DEFRA was aiming for by 2030. And part of my project is looking at soil management. I work at Rothamsted, and we had our 175th anniversary at the weekend, and particularly on earthworms, because the things, when you change soil management practices to reduce tillage intensity, there are lots of things that change, but earthworms are one of the biggest variables in terms of the biology that you'll see changes in. And I used to be invited to give talks about earthworms, and I give talks about earthworms. And people will go to me, Jackie, what's a good worm population? And it's a difficult question to answer as a scientist. There are so many different variables. And what I'd often do is I'd hand out the ecological guide by the Opal team. It's a really good guide. It shows you the ecology of your soils. You can look at your species. But then I took a second and I realized I wasn't actually answering the question I was being asked. When people are asking me, do I have a good worm population? It's asking me about the worm activity across a field. It's asking me about their functions. And it's very much looking at the sort of numbers you need to significantly benefit plant productivity, which is why I set up the 60-minute worm method. I just thought, why don't we have a bespoke method for use in agriculture? And at first I thought I'd ask about, well, I tried it out on some fields and some farms in the autumn last year through the AHDB funded Monitor Farms and Strategic Farms, and I was quite happy that it could work at a big scale. And I was thinking maybe I'd ask 20 people to give it a go, but I set the number at 100 because I thought I want it to be good. And I was so overwhelmed by the wonderful response by people who wanted to take part and give it a go. And certainly for me as a scientist, just that feedback, both the good and the bad, that came from it was really helpful and invaluable. Because when I give talks about earthworms, I didn't realise that many people perhaps have challenges knowing the difference between an adult and a juvenile earthworm. And not being able to tell that difference means you don't really know the ecological group of what you're looking at, unless you miss a whole raft of information you can get. So certainly just by working together and just getting that feedback, I mean the 60-minute worm survey ended up with over 14,000 worms being counted across the country. And it sort of brought everyone together. I was surprised, I mean, organic farmers took part and no-tillers for a long time took part. Horticultural people took part too. I mean, lots of people gave this a go. And just that feedback from the different sectors helped improve the method in a number of ways, helped me see where I could help and bridge some of those gaps in what I know, for example, how to identify the different earthworms, how we can do that. And then also, you know, as Jake said, going out there and digging, taking a soil pit and looking at your soils, I mean, that's useful. But if we have the same method and we're all doing it at a similar time of year, suddenly we have a powerful data set and database that means we can compare with each other. And it's much more powerful then as a resource. It's just coming together, spending that time, and then sharing with the same method. I mean, that's science. And then from there, move forwards. So I strongly encourage you to go and talk to all the scientists that are here. I mean, I think we've got Cranfield, Rothamsted, Harper are here too, AHDB Great Soils Project. We're here and we're here to listen. So just come and tell us what you need and we can help look at those things. And just thank you very much for all the people who took part in the survey, and I hope to continue to support soil science during the rest of my fellowship. So thank you.
Thank you very much, Jackie. I did, when talking yesterday, ask you to say why it is that science on this side is so weak in the science community, and you explained that the government has been wrecking science on this side since the 2000s, and certainly in the present period they've also been cutting. So the reason we haven't got lots of deeply informed soil scientists and ag scientists here is they're not paid for anymore. So we have a very strange position in this country with respect to And finally, we've got Gottlieb. He gave a brilliant presentation this morning, which he's got to digest into 5 minutes. But he has vast experience and did tell us a great deal this morning about the experience of the EU in dealing with this idea of what should be measured and where it should be measured and what the members should do and what the EU should do. And we look forward to that. You also have a video. Yeah.
Well, good morning, everyone. Well, I won't talk about my experience as president of ECAF and the EU. I rather talk about my experience now on measuring soil quality within a project, a European H 2020 project called iScaper, which is an interactive soil quality assessment for agricultural productivity and environmental resilience. And I think this is a rather, new, or no, it's not a new approach, but innovative approach, because we are trying to assess soil quality. And by the way, we deliberately use the term quality and not health, because, well, I know farmers prefer to use the term health instead of quality, but quality is, covers, I would say, everything, both the manageable and the inherent soil parameters. So we call it quality, but of course it includes especially the manageable properties of the soil. And within this project we have different approaches to look at soil quality. One is looking at different management practices and how those influence soil quality. And to assess the soil quality and the differences in soil quality as influenced by the management practices, we identified in one of the work packages a set of indicators. And well, we all know that soil quality, well, often, and especially soil health, often cannot be measured directly in one unit, or therefore we need indicators. And well, yesterday we already talked about these indicators. It's not easy to get the right indicators. To use indicators, we also should look at the different soil functions, because some indicators give you a better idea on specific soil functions, where for another soil function you should actually use other indicators to assess the response. And well, in this project we made a review of a lot of indicator approaches and soil quality assessment approaches, and we classified them in different groups. Of course, it's the physical, chemical, biological, microbiological, and well, they are all classified as well as a function of the soil function we want to address. At the same time, we have another approach which is more practical to assess soil quality, which is the visual soil assessment. And finally, we also try to develop a soil quality index which is integrating different indicators that are looking at the different soil threats. So the point of view of soil threats is also an issue in this project. Well, it's in the middle right now, this project, but well, we are all working in the development also of a soil quality assessment application. This application should actually, when it's finished, and we are working from different sides, from the analytical side, from the visual soil assessment side, and also using databases that exist on the different indicators. We are approaching this from several sides in order to improve this application, which you can download and use on your mobile. And we are trying to calibrate it and to improve it. And at the end of the day, this application should allow farmers to go to the field, to download data that exists on the surroundings. He can confirm or can add his own data, and then allows him to assess actually his soil quality under his feet. So, well, we will see whether it will work, whether there is, well, some useful outcome of this soil quality application. But this is what we are assessing right now. We are looking, as I said, also to soil threats. And regarding soil threats, well, we were asked in the Icecraper project to produce a film for dissemination, and I very briefly would like to show a film that I made for this.
Agricultural soils suffer from multiple threats, such as soil erosion, soil organic matter decline, compaction, biodiversity decline, amongst others. These threats put at risk the correct functioning of our soils and its consequent contribution to the delivery of the manifold ecosystem services, most of which are soil mediated, such as the provision of food, feed, fiber, biofuels, the regulation of climate, water, and soil diseases, as well as the supporting services like water, nutrient, and carbon cycling. Soil quality is the result of both inherent soil properties, such as texture or mineral composition, and dynamic properties that may be influenced by its management. The way soil is managed should enhance favorable soil conditions, which can only be found in natural ecosystems, forests, or grassland. Thus, the simultaneous application of the principles of conservation agriculture that mimic natural conditions, which are minimum soil disturbance, permanent soil cover, and plant or crop diversity, can be considered as a promising set of farming practices capable to harness soil quality and functions.
So, well, you saw kind of this, you see here Tony Reynolds, some of these short clips were already, well, provided by him or his grandson, Sam Curtis, so he, well, many thanks to him as well. Well, and we are, in this project, we are looking really at different agricultural management practices that are supposedly capable to influence the manageable soil properties, and comparing those both in long-term field trials, but also on farmer sites, paired farmer sites, and the application and of the soil quality assessment. Well, we will see with the results whether we are capable to identify real good management practices capable to improve soil health and quality. So, Tony, thanks.
Thank you. Well, thank you, speakers, for being brief, and we have quite some time for discussion. Can I just try to frame it a little and give people time to frame questions? And I'm going to ask John Landers to say something about his Brazilian experience and a moment when things shifted dramatically as a consequence of much lobbying, but then just a little tip into Embraca picking up the idea. So what are we trying to do? We've got CA put in place by enthusiastic farmers, they're in the room. They need to communicate metrics because even the most CA fervent person realizes that just a few metrics saying you make more profit or you make more yield or something that everyone can relate to, even if they don't properly understand it. But we are suckers for metrics. We are addicted to metrics. We need to make sure that we can have them. We're not going to get them from government or from the corporates or from science at the moment. So it looks as if the community, which has done so much to lift itself up to the position it's in, is going to have to, if it does recognize that the metrics are important on soil quality, let's call it soil quality, you're going to have to find some extra energy to express and communicate how the metrics will look, what they'll do, what their purposes are. So if you can relate to that and also perhaps provide advice. I know we haven't got anyone from DEFRA in the room. I sense we presumably still have quite some people from Natural England, so I'd like to hear from them, because they are the link between the farmers and payments, because the payments to farmers are done through Natural England. So their position, although they're not legislators, they are implementers, and they obviously know what works and doesn't work, or what's difficult and is even more difficult. So can we perhaps have those people in position to ask questions? And can I, could you give the microphone to John, if you could just tell us in 2 minutes the anecdote you told me yesterday. John Landers farms in Brazil successfully.
Thank you for giving me the honor to speak to this wonderful group of enthusiasts for no-till. My first no-till was in 1976, and it was a disaster, and I lost my job. But after that, I had seen the light, and I became a farmer, and I made it work. But I would like to correct one thing. The original research on zero tillage began with the GTZ working with a farmer in Paraná State, Herbert Bartz, and also ICI, who obviously wanted to promote paraquat, okay, but they gave a research grant to the Paraná Agronomic Institute and to the Embrapa Wheat Research Institute in Rio Grande do Sul to work on zero tillage. And the Paraná people produced the first manual in 1981. We only got Embrapa really on board in 1996 at our national meeting, when the president got up. I had nobbled him beforehand, mind you. He got up and he said he called upon his scientists to catch up with the farmers, because the farmers were ahead of them. And this is a technology that has always been pushed by farmers, and we have to respect that and demystify some opinions of scientists. Farmers' observations are pure gold because they're trained observers. They may not make the scientific interpretations correctly because they haven't had that upbringing. But we must divorce interpretations from the farmer observations, which are pure gold. They're not replicated, but you don't throw them out the window because they're not replicated. They are pure gold. And we must understand that for scientists to set up experiments on zero tillage, they have to listen to the farmers and see where their problems are, and not imagine them and set up nice little trials which the farmers may not relate to. So we need to engender a tremendous working together of scientists and farmers, and we've got to bring the scientists onto the farms to understand the farmers' problems, to then design their experimental techniques.
Thank you. Okay.
I would like to say a very quick one on indicators. I'm fairly practical, and I would condense it into 3. One would be the infiltration rate of the soil, which reflects a lot of the soil characteristics. It's a difficult thing to do in the field, but it's worthwhile. Secondly, I think carbon is absolutely important. The scientists will say which measure we need to use. But the third, I think, I had a discussion with Joel yesterday, is the internal respiration rate in the soil, which reflects all biological activity, and all biological activity is an expression of how the soil is working for us. So I would suggest those three. Thank you.
Thank you very much, John, for... I think we need to go away from here with the idea we need a 1996 moment. And there's an awful lot of work got to go into that, apart from digging soil and counting worms, unfortunately. It needs clever politics in order to get that achieved. We have a question over here. If the panel could remember the three indicators, qualities, which John mentioned, and perhaps comment on them at some point, but we'll take a question here.
My name is Graham Willis, here in a private capacity, but I work for CPRE. My point would be, I know there's been some scepticism about the government, and DEFRA were here yesterday, but the 25-year environment plan set out that within 6 months the government would say how it was going to develop soil metrics, and it strikes me that's a really important opportunity, whatever we think about how that might be done and the science that might underpin that. One aspect must be, I'm sure, for me seems to be evident, given the problems with countryside stewardship and the way funding is going, is that those metrics need to work for farmers and for the government so that funding is tied to the metrics so that farmers get paid. I mean, we talked this morning about the difficulty of transition from conventional to CA models. And so it strikes me something needs to link those two things together to metrics. I guess, does the panel think that that's doable? Because we need metrics that work for farmers so they can upload data that works for them, but also metrics that work for government so that it ties to a funding package. So I think that's probably my fundamental question. And probably a second question is, the government's target is to sustainably manage soils by 2030 and wants to do that. The metrics must drive towards that, but do we know what sustainable management means in those terms?
Okay, thank you. As I said, Natural England's in the room. I will come back to them. Could you, the panel, respond to the three qualities which John mentioned? If you feel inclined, you don't have to.
I could provide some comments about working with farmers, actually. For example, at Rothamsted, we've just set up a new 100-year experiment looking at tillage and rotation management practices, and part of that we're introducing, the standard practices for no-till research, and we've invited researchers. For example, Crosslot came and visited us, and I asked for a list of key research needs they felt were needed, and came together and gave us a list of 8 key research areas. So as scientists, we do try to invite and encourage people to come and see us and talk to us. And then where we can find funding and opportunities to do that, that's what we're doing. So I'm a bit disappointed to hear quite a lot of negativity about science, because we're actually out there doing what we can to make changes.
Yes, thank you, Jackie, but you did explain to me yesterday why you can't. It's because governments have not been providing funding, and therefore you put in many, many bids for funding, but it's filtered out by the process. I
think it's fair to say there's been a big change in the funding climate. If you look 15 years ago, DEFRA used to fund agricultural research quite intensively and funded many research centres, such as, we had Silso, we had Long Ashton. And if you look at now the funding climate, many research centres are now funded by different research councils who are more biosciences based, so it's much more plant sciences. So there has been that loss of funding in those areas, for those areas of science. But that means we look for new mechanisms and new opportunities, and there's certainly been a recognition of the loss of expertise, which is why there's been new funding, particularly for younger scientists, to try and get back there and restore that expertise, and through different mechanisms. So hopefully, we can build from that.
To answer the questions that you posed, I think obviously respiration, organic matter, water filtration, those are all very valuable and appropriate metrics. What Joel said about the plant being the report, I think various people have said, the best way to assess soil health is by looking at how the plant itself is growing. And I think that's a intimately more sophisticated and nuanced of a report than anything we can get from a lab is going to be actual plant health. And then, so the question then becomes, how do we discern relative plant health and what its correlations and implications are? Brix refractometers, people, the general rule of thumb is a Brix reading of 12 in the leaf at, first thing in the morning, 7 o'clock in the morning, is symptomatic of a well-functioning overall system. That's a very, very simple metric that can be discerned by a farmer in real time. The issue then, in many cases, or just about every single case, is I'm at 4, now what do I do? And only when we have practical, nuanced suggestions for how to improve system function do we actually have science being developed for the benefit of the farmer and to facilitate the results we're looking for. I think we in general understand the principle that we want to do a better job. The question is, it's a nuanced dynamic, and how do we facilitate that process? Your question about, or your point about, the incentives that come from the government for farmers, I don't know exactly the nuances of how it works here, but certainly in North America, it's quite clear. As long as you engage in the industrial system, you get money. If you don't, you don't. We're very cynical in North America about the close partnership between industry and government. I think in previous historical times it was referred to as fascism. Let's just call a spade a spade. There's a serious issue here where the incentives of profit, of corporate interest, are perverting this process, and until we can actually acknowledge that and address these things in a much more systemic manner, looking at where our power lies and how we can come together and look at life as a sophisticated, nuanced, living system. Until we can really shift that paradigm, I don't know what the value of science is. Farmers, at least in my experience in North America, have written off the science, the scientists, the universities, the agronomists, pretty much categorically, because they're coming from this reductionist paradigm. They're not looking at it from a living system perspective. So, yeah, there's lots of opportunity here, and I think certainly the things you suggested are appropriate. That's probably enough for me.
Thank you, Dan, for moving minds again. You really spoke very powerfully there. Thank you very much. Does anyone else want to say anything about it?
I couldn't agree more on the three metrics there. I just wish that we'd had more baseline stuff when we started off to actually be able to measure more. And I think that's something that if people are just starting out on that, do the infiltration rates, count the worms, because in 5 years' time you'll know where you'll be. And in answer to the question from the floor, I think when we looked at doing high-level stewardship in 2010, there was a direct drilling option, which paid a flat rate. I think it was £60 a hectare for taking that option up. And I think that's something that we could look at in the future as a way of getting that payment out to farmers who are in this transition period. I think if you're going to do direct drilling, you're going to do no-tilling, you need to commit to an X number of years of doing that on that field. And I think the soil health will come in time, because in order to do your direct drilling, you'll be doing cover cropping, you'll be doing all these other things and manures. So as a result of that practice, that no-till practice, for your business to make it work, you will, by its very nature, be improving the soil as you go along. So it's also something very straightforward for the RPA to inspect as well, in terms of they walk into the field, do they see cover crop, do they see crop residue, or do they see a brown cultivated bare soil? And that to me is kind of black and white.
Could I just also say on the metrics one there, I think that the reason it's such a difficult, you're really on point bullseye here, is that trying to nail down, well, what is the metric and how, therefore, is the government going to pay and reward that? And we reach these really difficult topics, and soil carbon is a perfect example of this, where, well, sure, if you do certain practices and that builds carbon and you get paid for that, well, what happens if we have a dry year or a couple of dry years and actually soil carbon then begins to decline for other non-management reasons, other environmental reasons? Well, do you have to pay that money back now? And these are really difficult, questions to answer, and how to lay out protocols and practices for this, for that exact reason. And I think we have to also be careful of designing the system solely around that metric. It has to also have some element of process and practice behind it. So it's not just about reaching the target. How did you reach the target? There are many ways, and there's always many roads to Rome, and some are actually better than others, and there's always little cheat ways here or there. Could I take my soil sample and throw in some extra whatever, carbon or whatever, before it gets sent off to the lab, just as one small example? So it has to have an element of process and practice, I think, behind that. And then lastly, on subsidies. There's a lot of evidence that suggests that motivations for practices, farmers' motivations for engaging with agri-environment schemes and for doing the right thing, is that when there is a financial incentive, when there is that subsidy, that becomes the motivation for doing the activity. When there is no financial incentive, actually there becomes other motivations, more altruistic, I want to improve the health of my soils, I want to help my landscape, my environment, my wildlife. And the farmers' motivations lean towards that way when there is no financial incentive. And the evidence suggests that when those incentives are, when we go down that path and when farmers go down that path, that actually those have more longer sustaining benefits, more sustained effects, and you carry on those practices rather than you will start, stop when there's money involved. And I think that reflects John's point about this whole no-till movement. It being farmer-driven, it hasn't come from top-down, and look at the energy and etc. and the impact of it worldwide.
Yeah, could I just ask the panel again, and perhaps people from the room, to respond to one of the points you made, which was we've had the invitation from DEFRA to respond to the 25-year plan, environment and farming, and I just wondered if people felt that there were indicators with the necessary precision to help that process along. Precision is the method you use to come up with a number which might be accurate or not, depending whether the method is precise enough. But would anyone like to say anything about that? I sent in my response to it, actually. I responded to the invitation. I know that this farm did. I presume it took you a few evenings or weekends to fill in. It was a big job. But and do the Natural England people in the room, are they optimistic about whether the metrics are going to come up to enable them to implement whatever it is they will be providing payments to get farmers to do what at some point the legislators think is the right thing? So 25-year plan, any comments? The precision of the indicators.
Just a comment on methods and things. It's certainly good to get out there and have a look. And with the worm method, it came from people asking me how to measure worms, and the feedback was areas of education that were missing. For example, how to identify different types of worm. And as a scientist, you don't necessarily appreciate the little nuances in there. That you set a method and then getting the feedback is quite helpful. And in terms of the method, we're able to calculate the error rates based on the sorting, the error rates, compliance, confidence in the data, other people's confidence by speaking to the people who got involved. And certainly a lot more of the soil health work, for example, the AHDB work, is having lots of workshops with people taking part and providing that feedback in order to look at the confidence levels and compliance levels of collecting the samples, because a key part of all soil measurements is where you take your sample from. And in fact, it's one of the most common questions I'm asked. Where's the best place to sample? So just finding those opportunities and just going out there and trying to measure something. There are great how-to videos out there and other soil health things to do. Give it a go, see where your challenges are, and provide that feedback. And that's how we can get better methods and metrics by working together.